Hello and welcome back. This video will explain what bond energy data is and how to use it in calculations. So, what is a bond energy? A bond energy is the amount of energy needed to break 1 mole of a covalent bond. So essentially, however much energy used to break a bond will be released when a bond is made. They're equal. This means that if you have the bond energies of a molecule, you can calculate the overall energy change of a reaction without having to do any actual practical work. The bond data for a certain bond is the average of the data found in experiments done by researchers for that specific bond everywhere, just a combination of them all. Using the bond energy data is quite simple. Total energy released when the product bonds are formed, subtracted from the energy required to break down the reactant bonds, is equal to the total reaction bond energy. Total bond energy can also be used to determine if a reaction is exo or endothermic. If the total bond energy is positive, the reaction is endothermic. And this is because the positive total bond energy means the reaction has gained energy from the beginning to the end, and endothermic reactions draw on energy from the surroundings. The opposite is true for exothermic. Its total bond energy will be negative, and that's because it releases energy to the surroundings. I'm going to go through 2 examples and then we'll be done. Example 1 is the reaction of hydrogen and chlorine to make hydrogen-chlorine. If you write that in terms of bonds, the reactants have 1 hydrogen-hydrogen bond and a chlorine-chlorine bond. The products have 2 hydrogen-chlorine bonds. Here is the bond energy table. It shows the bond energy for each bond. So to start off, the reactant energy is 436 plus 243. Because those 2 values correlate the hydrogen-hydrogen bond and the chlorine-chlorine bond. This makes the total reactant bond energy 679. Repeating that with the product energy, you result in 864 due to the addition of the 2 432s. These obviously correlate to the 2 hydrogen-chlorine bonds. And when you subtract this product energy from the reactant energy, you get minus 185 kilojoules per mole, total energy change. As this energy change is negative, the reaction is exothermic. The second example is hydrogen-bromine becoming a hydrogen molecule and a bromine molecule. Once again, here are the bond energies. As before, the reactant bond energies are added together to get 732. The product energies are added to reach 629, and when you subtract the products from the reactants, you get positive 133. However, the total energy of this reaction is positive, and that means it's endothermic. I hope you've all followed and enjoyed my 2 videos and have actually learned something. Bye.